Okay, this is Wednesday, November 17th. So we're not going to go through and do all of these. Now, I'm just going to kind of talk through number one here. If you see something like this, what could we maybe do to make this a little bit easier on ourselves with all of these terms? They look like they're in a weird order. Yeah.
Put them in order.
Yeah, just rewrite it in order. So we like to have that x squared term first, that x term in the middle, the constant last. We're not going to go any further with that one. You could factor out a 3 right away and keep going from there. But I have that case again in number 2. Number 2 we're going to do together because this one has z's and b's, but the whole process is still the same. Sometimes students get confused with more than one variable. So let's do this one together. Now this one's a little tricky because I see b squared and I see z squared. So we're going to list our z squared term first because it's positive, but technically you could do this either way. I'm going to list my ZB term in the middle, and then my B squared term last. Okay, so you might have to do a little reordering before you factor. So I'm looking at my trinomial here. Is there anything I can factor out right away? 2, right? Okay, that's our first step. Always factor out the GCF right away. That would give me 12z squared minus 5zb minus 2b squared. Then I ask myself, how many terms do I have left? I have 3 terms, so then I look, do I have a 1 or do I have a number in front? I have a number, so I'm going to have to do that AC method. Okay, you learned that yesterday, so this is good review. Okay, so we do A times C. Now, I know that's not like a constant. You're like, there's a B squared on there, but this process still works. We're going to do 12 times negative 2, which is negative 24. So you take that product and you still find 2 numbers that add to negative 5 but multiply to this A times C. Let's move this over here. This A times C. So I need 2 numbers that multiply to negative 24 and add to negative 5. Sid, you have those for me? Those 2 numbers?
Oh, no, I don't.
Oh, that's okay. What? Oh, what were you going to say, Wesley?
3 and negative 8.
Good, negative 8 and 3. Thank you, both of you. Okay, those 2 numbers. So what we do with those 2 numbers is we split up that middle term using those 2 numbers. Now, look at the variables on negative 5. I have negative 5 ZB, right? So when I split up my numbers, I have to do negative 8 ZB and plus 3 ZB. Those have to add to the middle term. So just copy whatever variable you have in the middle there, and this process will still work. All right, then I have 12z squared minus 2b squared. I know I have this 2 outside. I'm just going to draw this arrow to remember to just drop it down to my final answer that I factored out 2. You can do that. All right, now we factor by grouping. So split it in half. I look here. I have 12z squared minus 8zb. Their GCF would be 4z. And I'd be left with 3z minus 2b. All right, everybody okay with that? We've practiced just factoring stuff out like this, and that Alex activity is a really good one of just practicing factoring out. Okay, remember, if we're left with 3z minus 2b, that's what we want to be left in our second group. And I look here and I see GCF is a b, positive b. So this factors 3z minus 2b and 4z plus b. And then don't forget about that 2 that we factored out right away. Okay. Does that make sense, everyone? It's still the same process, even if there's some more variables than just 1. Okay. This technically would have worked if we listed the negative 4b squared first, but then I would want to factor out a negative 2. Okay, anytime your first term is not positive, if your first term is negative, we want to factor out a negative to make our first term positive, make your life way easier. All right, I don't think I'm going to do any more on here. If we have time, we can come back or maybe as a little warm-up tomorrow, but I want to focus on solving equations today, which has factoring obviously like embedded in it, so it's just more factoring practice. Okay, here's just a little vocab overview. I really like this kind of diagram here because we do a lot of like factoring and there's a lot of words that kind of mean the same thing but a little bit different. Okay, so if I have just a plain old expression, so guys, an expression is in a math is just a bunch of like numbers or letters with no equal sign. Okay, so everything we've done so far have just been expressions. So when we factor it, these we call roots, or sometimes they're called factors. Expressions have factors, so this one has a factor of x minus 3 and x minus 5, or sometimes they're called roots. Okay, what we're going to get into today is equations. Equations have equal sign. Equations have solutions. If I were to make this a function by putting y equals in front of it, if I were to graph this, these are now called zeros, which on a graph, we know the zeros are the x-intercepts, but these all kind of go hand in hand. All right, you guys have solved equations like this by graphing. You did it on the quiz. You graphed, and then you looked at approximately where the x-intercepts were, right? So now we're going to solve these algebraically. Without having to graph, we'll be able to figure out where the x-intercepts are. And the nice thing about solving algebraically is you'll get exact answers. So if you have like in between -1 and 0, maybe it's -1/3, we'll be able to find that exactly by doing it algebraically. Okay? All right, so let's try some. Now, before we get to solving, you have to understand this one product property. It's called a zero product property. I often just say ZPP, zero product property. It's kind of common sense. If you have two or more, this could apply for any number, factors being multiplied together, like let's just do A times B. If their product is 0, the only way we can multiply two things together and get 0 is how? If one of them is 0, right? So if A times B is 0, A is either 0 or B is either 0. That's a ZPP. We use that when we solve equations. Okay, now notice these are different than the ones we've been doing the past couple days because now it's an equation. There's an equal sign. I know there's no directions here, but they're going to be solved by factoring. We'll get to that. Solved by factoring. Okay, so what you're going to do, every single time you're going to set these equal to 0. That's already done for me. The reason why you want to set it to equal to 0 is because we're going to use the ZPP at the end, okay? First order business, set equal to 0, that's already done for me, and then we factor. So here, anything I can factor out right away? No. How many terms do I have? 3 with a 1 in front. Oh yeah, you guys remember how to do those? You can jump right here. You can jump right there. You can do AC method with the ones with 1s in front. You can, but this is way quicker. And then we just got to find our two numbers that multiply to C, which in this case is -2, and add to B, which is -1. All right, well, obviously the only way to multiply to 2 is 2 times 1. So if they have to add to -1, it would be -2 and 1. So this factors to x minus 2 and x plus 1. But now it's equal to 0. Now it's an equation. Think about when you solve equations with just like plain old taking off the layers around x. Your final answer is always x equals something, right? So now that we're solving, we need values for x. We need solutions. Here's where the ZPP comes into play. I have two factors, x minus 2 times x plus 1, and their product is 0. So the first factor could be 0. That's one possible solution. Or the second factor could be 0. You set up too many equations. That's why we always want to set it equal to 0. This becomes really easy to solve. We just add 2. We get x is 2. And we get x is -1. You could go back in, plug those in there, you'll get 0 into the original equation. Side note, if I was to graph this, first of all, this would be a happy face parabola or a sad face parabola? Happy. I have a leading coefficient of +1. This would cross my x-axis at -1 and at 2. That's what you guys just found. And that's what the last slide is kind of talking about. Those solutions on a graph are your x-intercepts. Okay? So, when you're asked to just factor an expression, you stop here. There'd be no equal sign. If you're asked to solve, you have to tell me what x is. Some people get that confused. All right, try another one. This one, before I even start factoring, I have to set it equal to 0. So that's not hard to do. I'm just going to move over the 5. And then I go through my little factoring flow chart in my head. Anything I can factor out right away? No, 13 is prime. Okay. How many terms do I have? 3. With the number in front. AC method. 6 times negative 5 is negative 30. So I need 2 numbers that multiply to negative 30, but add to 13. Thanks, Brayden. 15 and negative 2. So I'm going to split up 13x as 15x minus 2x. So right now I'm just factoring, but this is technically still an equation. So I still want to add in that equals 0. Then I can factor by grouping. Here I could factor out a 3x, and I'd be left with 2x plus 5. What would I need to factor out of that second group to be left with 2x plus 5? You can shout it out. Oh, sorry, what did you say? Negative 1. So this factors into 2x plus 5, 3x minus 1. Now, if this was an expression and they just asked me to factor, I'd stop right here. But it's not. It's an equation. It has an equal sign. So I gotta take it one step further, apply the ZPP. If I have a product that's equal to 0, each factor could be 0. So take your 2 factors, set them each equal to 0, make little mini equations for yourself, and then you'll be left with something you know how to solve. So subtract 5, divide by 2, negative 5 halves, add 1, divide by 3, and 1/3. Great example why we solve something algebraically. Because on a graph, if it crossed at 1/3, that's pretty hard to tell exact, right? You guys, all you've done right now is you're like, oh, it's in between 0 and 1, but now we have an exact answer of where it's crossing. Okay. Questions so far? If you have your factoring out, if you've been keeping up with your factoring practice, this is not much harder. You just take it one step further. Okay, I like this example. I actually want to change this equation. Let's do this. Let's start off like this. Let's do this, because sometimes people get this confused. It's the same equation, I just rewrote it differently. So some people see this and they want to divide both sides by h. We cannot do that because h is a variable, which is a number, and in case that number is 0, you just technically divided both sides of the equation by 0. So since it's an unknown, you cannot, I repeat, you cannot do this because you don't know what this is. It could be 0. It's an unknown number. That's what variables are in math. So same process as before. We're going to set it equal to 0. So I always try to keep that first term positive. So I'd subtract over, and that's how the equation was set up. And then I start with, what can I factor out right away? H. You're left with h minus 2. How many terms do I have left? 2. Any perfect squares? No. So we're done factoring. We're done. ZPP, I have 2 factors here. H is a factor. H could be 0, or h minus 2 could be 0. There's a solution, and that's the exact reason why we couldn't divide by h, because look, it ended up being 0. So if we would have done that in the first step, that's a big math no-no. We get 0 and we get 2. So if your GCF, folks, in your first step, if your GCF is a variable, it ends up being a solution. Let's look at when that doesn't happen. This is another great example. Okay, this one's already set equal to 0 for me. What's my GCF here? What can I factor out? 3. How many terms do I have left? 2. Perfect squares? Is 1 a perfect square?
1, yeah, but on negative.
Well, remember, difference of 2 squares. This actually factors further. This is a difference of squares. And remember how my difference of squares factor?
It's minus 1 is plus
Good, yup. X plus 1, x minus 1. There's my fully factored answer. Now I technically have 3 factors in this. 3 is a factor, x plus 1 is a factor, and x minus 1. Could 3 ever be 0? No. So when your GCF is a number, you don't really need to set it equal to 0. And think about this, guys. In our first step, can I divide both sides by 3? Yeah, because it's a number. We could have done that. We could have just divided. Oops. We could have just divided both sides by 3. You can't divide by a variable because you don't know what it is. All right, so then we have x plus 1 could be 0, giving us solutions of -1. X minus 1 could be 0, giving us a solution of +1. Because we're practicing factoring, I want you to solve it this way. I want to point out, in real life, Miss Henchurch, could we do this? Could we just set this equal to 0? Square root both sides and get plus or minus 1? Yeah, totally, you could. You could do that. And we get the same solutions, right? But because we're practicing factoring, I want you to look for these special difference of squares and factor it instead of solving it with square roots. All right. Any questions? All right, let's try some more. Solve by factoring. Number 1. Wow, set equal to 0 for me. Nice. What can I factor out right away?
Nothing.
T.
Can't you not do that because you can't divide by t or 0 by t?
Right, but I can factor it out. I just can't divide it out.
Oh.
But I can factor it out, and it's going to end up being a solution. Yep, good question. So we can factor out a t, which means you just have to leave it outside here. There's no numbers that are common here. All right, I can factor out a t. How many terms do I have? 3 with a 5 in front. AC method. See how much AC method practice we're getting today. 5 times 18 is 90. Ooh, this might be a tricky one. 2 numbers that multiply to 90 and add to -21.
-15, -6.
Nice, Carter. Say thanks, Carter.
Thank you, Carter.
Okay, so we're going to split up that middle term. Doesn't matter which one you put first. -15t minus 6t. Make sure it matches the variable. It does. 5t squared plus 18. Celeb is t. Factor by grouping. All right, here I can factor out a 5t. We left with t minus 3. What would I need to factor out of my second group to be left with t minus 3? Or bigger? Bigger. There's a bigger GCF of 6 and 18 inside 3.
6.
6, -6. Okay. So this factors into t minus 3, 5t minus 6, and we still factored out that t. So guys, just remember, you can't just divide both sides by t. That's what I meant by that. You can't divide off that t. If it's a number, you could, but variable, you can't. All right. If they asked me to factor, I'd be done. But I want to solve, so I need solutions. I need answers. T could be 0. Don't worry about that one. T minus 3 could be 0, or 5t minus 6 could be 0. So final solutions of 0, 3, and this one will be 6/5. I don't think we need to do number 2. It's like very similar to the last one. Let's jump to 3. Okay, so this is one you could technically solve using square roots, but we're practicing factoring. Anything I can factor out right away of these 2? No. How many terms do I have?
2.
Do I have any perfect squares?
Yeah.
Yes. So how I kind of show my work for this, you don't have to do this. What's being squared here with 36x squared? 6x. Good. What's being squared for 1? 1. So this factors. This is one you just have to memorize. Those two numbers, opposite sign, 1 plus, 1 minus. Oh, I should also mention we would have to set it equal to 0 first, right? But that's already done for us. Now it's factored. I want to solve. I see an equal sign. That means I have an equation here. So I need final solutions. Negative 1/6 is one solution. Positive 1/6 is my second solution. Okay. How we doing?
Good.
Making sense?
Yeah.
Just takes practice. Number 4 is a little different. You might be like, oh, nice, it's already factored for us. But is our equation set equal to 0? Could I do, x plus 2 could be negative 18 or x minus 7 could be negative 18? No, that property only works for 0 because there's lots of ways to multiply to negative 18. Negative 18 times 1, 6 times negative 3, right? We don't know what these factors are. So what we're going to have to do, we're going to have to multiply this out, move over to 18, set it equal to 0, and then go back and factor. Oh, Wesley, you guys should have saw the look on his face. He was like, oh, right, let's do it. Okay, here we go, folks. It's not hard. X squared minus 7x plus 2x. Okay, so I distributed the x. Distribute the 2. Negative 14 equals negative 18. All right, I'm going to combine my like terms here of negative 7x and 2x and get negative 5x. And at the same time, I'm going to add this 18 over. So you end up getting this. Oh, nice. The trinomial, the one in front. Those are my favorite. All right, so you have to do this first. That's our first step. Set it equal to 0. All right, that's our first step. We have to set it equal to 0. Now we can factor. All right. Anything we can factor out right away? Anything common? No. How many terms do I have? Oh, what do you want to say, Sid? Oh, thanks. I swear it like does the motion of my hand. I swear I don't touch it. Okay. 3 terms, yes, with a 1 in front. Bingo. That's a little shortcut, the quick way to do this. Because the only way I can get x squared is x times x. All right, now I still need to do the process. What multiplies to positive 4? What two numbers? Multiply to positive 4 and add to negative 5.
Negative 4, negative 1.
Negative 4 and negative 1. Good. You can plop those in right away. We don't need to do AC method here because I have a 1 in front. You could do AC method if you want to, but I don't recommend it. It's way more work. Now, since this is set equal to 0, we can solve it. And we get 4 and 2. All right, folks, let me ask you this question. Why are we getting 2 solutions for almost all of these? These 2. Let's look at just these 2, because this one's not technically a quadratic. That one's a degree 3. These 2 are like quadratics. If we were to graph them, they would form parabolas. So why are we getting 2 solutions for a lot of these? It usually crosses the x-axis twice, right? Usually, with parabolas. Could it cross, or could we just have one solution? Yeah. Could we have no solution? Yeah, we could. I'm not going to throw any no solutions at you right now. Okay? That's in the future. They actually, a little preview, they actually do have solutions. They're just not considered real. Okay. Now I just got to do some word problems. I feel like we're going to go on time. What do we got? 11:09? Yeah, we're good. All right, so a lot of these word problems involve like area or sometimes like perimeter. Oh, what good geometry review.
Totally remember all of it.
Okay, so perimeter, no matter what the shape, you just add up all the sides, right? All right, now area depends on the shape. So let's just put in our notes kind of our different area formula. First, we have a square. What do we know about squares? All sides are the same. So let's say their side length is x. What would the area of that square be? x squared. X times x, right? X squared. Good. Rectangles. These are congruent. And these are congruent. Now, we often use the variables like b and h to represent the base times height. L times W is another column, length times width. So the area of our rectangle, we just take the length of the base times the length of the height, and that would give us that total area. Okay, those are a couple easy ones. All right, you guys remember the area of a circle?
R squared.
Pi r squared. Nice. R standing for the radius, so go ahead and just draw a little radii in there. Pi times your radius squared. Triangle. Anybody remember? Yeah, 1/2 base times height. All right, your base would be like this here. And then remember your height is like the perpendicular, like the altitude to your base. So this would be considered my height. If it's not a right triangle, you'd have to look at the perpendicular line to your base. All right, trapezoid. Who remembers this one?
Isn't it like 1/3 something? I don't really remember.
It's not 1/3, but it does have a 1/2. Okay. Close. B1 referring to like one of the bases, B2 referring to the other bases. It's the sum of the bases. And there's one other thing you gotta multiply in here. What will give me the actual area? The height. Yep. So it's half the height times the sum of the bases. Okay. Now those are in your notes, so you can look back and use them. We're gonna do a trapezoid one together. I think there's like a square or maybe a rectangle on your homework, maybe a triangle one. And remember, but if you need those area formulas, they're right there for you. Oh my gosh, I just love these. Okay, so this says solve for x. So I know my b1, I usually just call my shorter base b1. I know my b1 is 2x minus 1. Oh, doesn't this feel like geometry throwback? And on my second base, which I usually call like my longer one, is 4x plus 3. I know the height is x. I know the area is 114. All right, I'm just going to re-jot down the area of a trapezoid. I know the area is 114, whatever units they're talking about here. So I'm going to do 1/2 times the height. The height is x. Come on. Times the sum of my bases. So I'm going to call this one B1, this one B2. So that'd be 2x minus 1 plus 4x minus 3. Plus 3. Thank you. Okay. Let's go ahead and simplify in there a little bit. I would just call this 1/2 x. And then in here we have 2x plus 4x. We have 6x, negative 1, and positive 3 is 2. This is 114. All right, I would distribute then the 1/2 x. And it actually kind of ends up getting rid of those fractions for us because half of 6 is 3. Careful here, x times x. That'd be 3x squared. All right, and then half x times 2 would just be 1x. So what type of equation is this?
No, it's 0 if it was called the same.
Okay, we're gonna have to set it equal to 0. Is this a linear equation? If I were to graph this, would it form a line? No, it would form that U shape. Remember what we call it? Starts with a Q. This is a quadratic equation. So that should trigger that we got to set it equal to 0 when you have a quadratic. Because I can't just take off the layers around x. I have two unlike terms here. All right, so I got to move the 114 over. Now, you guys could solve this 2 ways. Raise your hand if you want to graph this and look at the x-intercepts. Raise your hand if you want to factor. Good choice. That's what I always tell students. Your first strategy should be factoring. not today, but eventually you'll get ones that don't factor, but don't worry, we have other methods for that. Other methods. Okay, anything I can factor out right away, folks? Anything common here? No. How many terms? 3. I have a 3 in front. What method? AC method. Let's do it. 3 times negative 114. Again, no matter how big these numbers are, this works. Negative 342. Oh boy. 2 numbers that multiply to negative 342 and add to 1.
Negative 18.
Yeah. Negative 18 and 19. Nice, Riley. Everybody say thanks, Riley.
Thank you, Riley.
All right. So let's make that negative 18x plus 19x. Again, doesn't matter which one you put first. Is this an equation or an expression?
Equation.
Equation has an equal sign, right? Equation. So am I going to stop after I factor or do I have to solve? I'm going to have to solve, yep. You're like, just wait, I'm not there yet. All right. Here I could factor out a 3x. I'd be left with x minus 6. Now, without even knowing the GCF here, I know I have to be left with x minus 6. So looking at my first term, I'm obviously going to factor out a 19, right? Because if this has to be an x, and I have a 19x, I'd obviously factor out a positive 19. And then you can check 19 times negative 6 is negative 114. So that's what I'm saying. You can, I use the word cheat, but you can work backwards is probably a better way to phrase that. Okay, so as I mentioned, this is an equation. I see an equal sign, so I'm not done. I got to solve. Now that it's fully factored, I can use ZPP. I end up getting solutions of 6 and negative 19 thirds. Ew. Now looking at my picture, x originally represented the height. Could we have a negative height?
No.
No. So you can ignore that solution. Height can't be negative. Height can't be negative. So our one solution here would be 6. Oh, that was so cool. Okay, one more number puzzle. And then we're done with it. I told you that lesson would take 3 days. Find 2 consecutive odd positive integers whose product is 323. Okay, lots of vocab here. Do you guys remember what consecutive means? Right in a row. Yep. Now, if they're consecutive odd, obviously I can't do like 3 and 4 because 4 is not odd. But 3 and 5 would be consecutive odd numbers. 11 and 13, right in a row, consecutive odd. All right, and they also have to be positive. So let's just say that my first number is x. Do you already figure it out? Okay, let's do it by factoring. All right, so my second number is whatever this number is plus 2. Because they have to be odd consecutive. So again, go back to my example. If one is 11, the next one would be 11 plus 2 would be 13. Okay? Everybody follow that? Thinking sometimes you're like, wait, plus 2, wouldn't that make it even? Not if this number is odd, right? Odd plus 2 more would be another odd. All right, product. We would multiply these. Product is 323. So when I go to actually multiply these, I get x squared plus 2x. I see I have an x squared, so I'm like, okay, this is a quadratic equation. I'm going to have to factor to solve, so set it equal to 0. And factor. Anything I can factor out right away? 1. Well, I mean, technically, yeah. No. How many terms? 3. With a
1 in front.
With the 1 in front! Oh yeah, get excited. You guys, doesn't that make you excited? It's like a wave clicker.
James.
Alright, what two numbers? Now these aren't my two numbers in the number puzzle. 19 and negative 17. Good. 19 and negative 17. So this factors into x plus 19, x minus 17. Is this an equation or expression?
Equation.
Equation. There's an equal sign. So I'm not done. I gotta solve. Okay. Now remember, x was representing our first number. So they're both odd, but it says odd positive. So which solution am I going to disregard? Negative 19, right? Okay, so my first number is 17. Meaning my second number would be 17 plus 2 would be 19.
Nice.
And that's how you can solve it using algebra 2. Oh.
Done.
Okay. I'm going to pass out the worksheet. Do you guys want me to go over any more of these, or do you guys feel like you got it?
Got it.
Because I can go over more if you feel like you need to see some more examples. I'm telling you guys, you have to practice this. You have to. And I also want to stress